Welcome to today's lesson. Today, we are going to continue with implicit differentiation. We'll see how certain functions can be differentiated implicitly. So, to begin with this concept, we'll first have to revise our chain rule, where let's pick an example. Let's say you have a function y, which is given you to be 3x plus 4, then all raised to the power n. Okay, let's say this raised to the power 4. When we want to differentiate a function of this form, what do we first identify? We first have to view this function to be the inner function. Let's identify that this 3x plus 4 to be a certain inner function, which is raised to this power 4, where we can let our u, a certain variable, let's say u, be equal to whatever is in the inner function. So this can be by 3x plus 4. It means that this inner function, wherever I see it, I can equally put u over there. Now, having this, our dy dx, or yes, finding the derivative of this y, will be this dy dx is going to be equal to, first, we identify that this inner function is now u, right? So we are going to first differentiate this function, where we are now going to have what? Our dy du. Now multiplying with what? Our du dx. Now where our u is this thing. Now let's proceed by finding what our dy du is. Our dy du will now be the differential of this function, where we are having our y is equal to u to the power 4. Alright, where our y prime over here, dy du, will now give us what? Our dy du will now give us 4 to the power what? 4u. This will be 4u to the power 3. So this gives us what? 4u to the power 3. Now we have equally differentiated the u, where we now have, no, this is when we have equally differentiated this function. We have to now differentiate what? The du dx, or differentiating the inner function. Taking that again, we have what? Our u to be this one, where we have our function y to be equal to this one. So our dy du will be the differential of this function. Okay, so the differential of this function is what we are having as what? Dy du. Because what? Y is depending on u. So we have 4u to the power 3. Now with this, we also have to look for our du dx. But what is our u? This is our u. So our du dx over here will be what? We differentiate this term. When we differentiate this term, we are going to have what? 3, which is what? Our du dx. Now, finding our dy dx, meaning that it is now going to be differentiated not with respect to y itself, but with respect to x. We introduce the term u. So, this will now give me, let me come back here. So, okay, putting that here, our dy dx will finally be, now what did we get as our dy du? Our dy du is what? 4u to the power 3, which is 4u to the power 3. 4u to the power 3. And this, taking that out, 4u to the power 3. And this is multiplying what? Our du dx, which is the differential of this one. And this is going to be what? Our 3. So we multiply that with our 3 here, which now gives us what? Our dy dx. By this, we can simplify further. But over here, we have to identify that our aim over here is to identify that our u over here depends on x and our y depends on u. Let's take that again. We see that this function y now depends on u, and then our u over here depends on x. So we can actually or equally draw a tree for that, where we will have something like, let's say, the first function is y, right? So my y over here, okay, where my y is now depending on what? My y is depending on u, where my u, let's take that to be here, is depending on u, where my u is also equally depending on another variable, which is x. my u is also depending on another variable, which is x. So we can check this pattern. And to move from this y to u, we are going to get our dy. Okay, let's put that here. To move from this pattern, we are going to get our dy du, right? Our dy du. Now to move from here all the way up to here. Now, okay, no. So moving from u to x, okay, moving from u to x, we are going to get what? Our du all the way up to what? Dx over dx. So this is the pattern we are now going to move. Now, which is what? My dy dx to be what? 3 multiplying 4, we have what? 12u to the power 3, where my u is what? 3x plus 4, right? So this is going to be what? 3x plus 4 all to the power 3. Okay. Now let's suppose that my function z, okay, let's say I have a certain function z, and then that function depends on a different function y. Okay, let's visualize that well. That depends on a function y, where my function y also depends on a different function or different variable x. And this different variable, let's say x, let's put that here. It depends on x. Okay. Then, if you want to differentiate this function all the way up to x, or differentiate with respect to x, we can visualize that on a diagram where I will have what? My z. Then from z, I know that I have to move to what? My y first. Now from y, I know that I have to now get to what? My x, which is, I have to get to my x, which is my destination. Now, to get to x, I first have to move from z to y. Having the derivative of my z, I get what? My dz all up to what? Dy. Then, now I now have to differentiate y with respect to x, which is now going to be my dy multiplying dx. The multiplication or the product of this gives me what? My dz dx, which can be visualized as what? My dz, let's put that well. My dz dx over here is equal to, first is going to give me what? My dz dy, okay? This is going to be my dz dy. And this is multiplying my what? This is multiplying my dy dx. This is multiplying my dy dx. Okay. Well, here we can visualize that what? The red one goes, the dy goes, and then I'll be left with what? Dz dx. Then from there, let's suppose that my z is equal to a certain function y, okay? Well, my z, okay, no. Let's say my z is equal to a function of what? Y, where that y is what? Y squared. Now, let's move still from, now I know that my z is equal to y squared. My z, which is equal to y squared, if I find my dz dy will be equal to what? My dz dy, my dz dy over here is going to be equal to what? 2y. So what does this give me? If my dz dy is equal to what? 2x, this is going to result in my dz dx, which is still, I'm still moving, differentiating the function with respect to x, right? So this is going to be what? First, I know that my dz dy over here is equal to what? 2y. So I bring my 2y, and then I multiply it with what? My dy dx. Multiplying that, and here we use what? The chain rule, as explained from the previous example, where that is going to give me my what? Dy multiplying dy over dx. Dy over. Now let's differentiate this implicitly. Having this question, we are going to differentiate it using the implicit differentiation method, where we identify that, let's say the first one, we identify that the function of y, we only differentiate that the function y with respect to itself, and then we multiply it by what? Dy dx. So as a simple trick, we're just going to have differentiate this 3y, which is going to give me what? It's going to give me 3. Then multiply it what? Dy dx. Okay. So this is going to be equal to, this is also what? Y to the power 2. I differentiate this. I'm going to get 2y. I just multiply it to what? Dy dx. I add that to differentiate this, which is going to be what? X to the power 2, and then I differentiate it, it's going to give me 2x. I differentiate this one, it will be minus 3y to the power 2. This is by the derivative of a constant, which is actually what? 0. Let's visualize this line again. We can visualize this line as what we actually did to result this is, let's visualize this as what? Where we just have my dy dx of what? 3y, which is equal to what? Dy dx multiplying y squared. This is also plus what? Dy dx multiplying what? X squared minus what? Dy dx of what? Y to the power 3 plus the derivative of the constant. Okay, dy dx of 6. So all this is what we resulted here. Okay, now we can see that we have finally, let's put every term that contains what? The dy together. Now we can identify that here this is y to the power 3. We need to multiply it with what? Dy dx. So I can take that away. Multiplying this with what? Dy dx. Why I have what? Dy dx. Okay, let's put all the terms that contain dy dx together. So I have here 3 dy dx. I bring this to the left side, minus 2y dy dx. I bring this also, I get positive what? 3y squared dy dx, which is going to result in what? Which is going to result in what? 2x. Okay, with this, I can factor out my dy dx. That is going to be what? My dy dx. I'm left with 3 minus 2y plus 3y squared, which is equal to what? 2x. Okay, which is equal to 2x over here. Now this that is equal to 2x, I can now do what? Make dy dx the subject, and that is going to be dy dx is going to be equal to, now dy dx is going to be equal to 2x all over 3 minus 2y plus my 3y squared. Okay, so follow me while in the next video we solve more questions of this sort. We solve